Hi everybody. So this is my second video on finding the points of intersection between a line and a curve. In this example, we've been asked to sketch on the same axes the graphs of y equals negative 2x plus m and y equals 1 over x plus 4. Then for part B, given that the line meets the curve at two distinct points, we've been asked to work out the range of possible values for m. So if we begin by sketching these two graphs on a pair of axes, I'll start with the y equals 1 over x plus 4. So if we say this is 1 over x and we're adding the 4 to it, well, that will be a vertical translation of 4 units. So that will move the graph up. So something like this, where our horizontal asymptote will be at y equals 4. Then if we sketch y equals negative 2x plus m, and I assume that m is a positive constant, this will have a negative gradient, but an intercept of m. And I'll label this asymptote as y equals 4. So for part B, we're given that the line and the curve intersect at two distinct points. So this means that the line cannot be where it currently is because it doesn't intersect the curve. So this means we're trying to find the intercept where the line is beyond this point or below this point. It can't be equal to both points at this point or here, because then it's a tangent and it only cuts the curve once. So if we begin by substituting this expression for y into here, we get negative 2x plus m will equal 1 over x plus 4. And then we need to multiply both sides of the equation by x to cancel out this division. So we get negative 2x squared plus mx will equal 1 plus 4x. And now we have a quadratic, we can make it equal 0. So 2x squared, moving this over to this side, plus the 1 plus the 4x, minus this mx will equal 0. And then we can factor in this x term. So we've got 2x squared plus x lots of 4 minus m plus 1 will equal 0. And we know there are two solutions to this equation because it intersects at two distinct points. So using the discriminant, we know that b squared must be greater than 4ac. So our b term is 4 minus m and must be greater than 4 multiplied by our a term multiplied by the c term. We can expand out this quadratic, so 16 minus 8m plus m squared will be greater than 8. Then we can move this 8 to the left-hand side. We'll tidy this up, so m squared minus 8m plus 8 will be greater than 0. And then we can solve this by finding the roots. So if we go to our calculators, we'll go to menu, we'll want the equation solver, option 2, we want 2 degrees, the coefficient of m squared is 1, the coefficient of m is negative 8, and the constant term is also 8. So m will be equal to 4 plus 2 root 2, and 4 minus 2 root 2. So if I sketch this graph now, and then we're looking at other points which are greater than 0, so that'll be in this direction and in this direction. So m will be greater than 4 plus 2 root 2, and m will be less than 4 minus 2 root 2. Okay,